Okay, so today we're going to talk about classes, and then next week we'll probably talk about objects. I'll probably, this is going to be the highbrow, what is a class, what does it do, and then next week I'll kind of give you the TLDR, kind of what you need to know, and then we'll start talking about objects, and then I'll give you some paltry assignment about making a object and doing something with it. So just so you guys kind of get the idea. But so what are classes?
The thing we're sitting in right now.
Uh,
Someone had to make a smart aleck comment.
If I was a nun, I would come smack your hand with a ruler right now, but I'm not.
Talking like social classes or
No. This is not a social studies class, even though sometimes I do talk about social issues.
I mean, is it the same type? That
No. Not even a little bit. Anyone ever done Java or anything? Okay. So essentially, classes provide a means of bundling data and functionality together. So kind of think of them sort of like functions, but bigger. So creating a new class creates a new type of object and allows new instances of that type to be made. So what's an object? Anyone ever done any object-oriented printing or object-oriented programming? So anyone have any ideas what the difference between an object and a variable might be? Nothing.
Nope. Not a clue.
Okay, good. Starting with a new slate. So what's a variable? We'll lie.
I say you're gonna make stuff taller than you
We'll lie. I mean, I guess I can do 5.9 because I'm like 5'8" and some change. So that is a variable, right?
Yep.
But let's say we want to make an object. Let's make. This is not correct syntax, so don't write this down. Just remember it. So Lee. So Lee is a new object. What are all of Lee's attributes? We can say Lee dot height equals, we'll say 5.8.
So are you basically saying that an object can be a defined function if you want to?
Sort of. Not really, no. Not even a little bit. I was trying to give you the benefit of the doubt, but no, that doesn't make sense. No. Let's see, Lee's IQ dot. We'll fudge the numbers a little bit. I'm a genius, and I'll write a genius. I mean, really, it's like whatever. So close enough. So what have I done here? What is this? What does this mean?
You create an object and then you're describing the object.
Right. I'm assigning attributes to that object. So rather than a variable, I'm making an actual thing, which is the basis of object-oriented printing. So like if you have a user who puts in a bunch of information, rather than say user one height equals something and then having to call these variables, you can just say, print all attributes of user. Or if you want to get something specific, you can say user dot whatever you want. So you're storing information into this object. So that's kind of what we're talking about. But the other side of it, the setting up and doing with of, maybe I should do objects first. We'll do classes. It's fine. Wish I had like one of those little book stands for my notes. Oh, I should have just brought my laptop from home. That's fine. I'll just look down. Really professional here. So each class instance can have attributes attached to it for maintaining its state Class instances can also have methods defined by its class for modifying its state. So what's a method? It's a function, yeah. Methods, functions, they're interchangeable. So a class can have within it something that changes it. So compared with other programming languages, Python's class mechanism adds classes with a minimum of new syntax and semantics. Python's got to do it its own way. It's a mixture of the class mechanisms found in C++ and Modula 3, which you guys have never seen before, so that's completely moot. Probably could have left that out. Python classes provide all the standard features of object orientation. So it includes a lot of C++'s object style with some of the syntax from Modula. So the class inheritance mechanism allows multiple base classes. A derived class can override any method of its base class or classes, and a method can call the method of a base class with the same name. Word salad. Like I said, I'm not expecting you guys to get this immediately. I'll show the examples that they give, and then I'll actually Monday or Tuesday I'll come in with my own and make it a little more simple for you guys. So this is like the science behind it. So objects can contain arbitrary amounts and kinds of data, just like Lee there. You know, those are just arbitrary bits of data. Doesn't really mean anything without some sort of syntax or seeing the whole picture, but depending on what you're doing with it, it can be useful. As true for modules, classes partake of the dynamic nature of Python. They are created at runtime and can be modified further after creation, so they are mutable. Okay. In C++, normally class members, including the data, are public except for the private variables. Whenever you're doing stuff in Java, and you say you want to make something within its own, like within itself, some variable that you pull in for itself, you can call that private, so that other classes, methods, whatever, can't call that specific thing. So essentially, you're making it a little more secure, right? Am I recording? Yeah, I'm recording. Okay, good. So they're mutable. You can change them unless you change them to private, but usually they're public. If you don't specify, they are public, which means this class and this class you can call something from that other class. All member functions are virtual, so they exist solely within that. So anything that you do within that doesn't affect outside stuff. It just all kind of exists within its own little bubble. As in Modula 3, there are no shorthands for referencing the object's members from its methods. The method function is declared with an explicit first argument representing the object, which is provided implicitly by the call. So whatever you're calling, you have to be very specific of what you're doing. Like, you can't just say run this. You have to tell it run self, run with this, run this part of it. It has to be very specific, which is really helpful if you're writing a really big program and you miscall something, or you just put in the blank. It'll say, what am I calling? What am I doing? So you won't make a memory error or burn down the server inadvertently. This provides semantics for importing and renaming. Unlike C++ and Modula 3, built-in types can be used as base classes for extension by the user. Also, like C++, most built-in operators with special syntax, arithmetic, stuff like that, subscripting can be redefined for class instances. So you can make plus do something totally different within the class. So it's, like I said, it's its own little bubble. It can still do what it's supposed to, but you can change it. You can pretty much do anything within it. So objects have individuality and multiple names in multiple scopes can be bound to the same object. So just like IQ, height, Lee IQ, you can bind just about anything to that object. that you seem fit. Like, what would this be? What might this be useful in? What kind of program?
A game.
Yeah, exactly. A game. So you can make your user an object, and then you can assign, has sword, yes, no, has torch, yes, no, has key, yes, no, rather than saying like, check this variable, which if you don't import it to different parts of your game, that'd be a problem. But if you have an object, regardless of where the object is in the game, those attributes follow it. So if you pick up a torch, has torch equals yes or equals true. So now you have that Boolean statement, and anytime you call that object, all those things are there. So it makes it a lot easier than hard coding it into every single thing. So like, say you have one room, it's its own little class or its own little function or method. We'll call it a class. So this room is a class, and in this room, there's a GRU. Anyone ever play Zork? Okay. So in Zork, you're in this room and you can move around, and if you look around, sometimes there's a dark room. If you go into a dark room without some sort of source of light, you get eaten by a bloodthirsty GRU. So whenever you enter a dark room, you can run a check on that object. You can say, does have light source, does have lantern, torch, flashlight, fire. And if all those are no, you just type out the end, you were eaten by a GRU. Start over, yes, no. So that's exactly right. Games, it's useful for everything, but games, I figure you guys would latch onto that a little easier. So this is known as aliasing in other languages. Usually not appreciated with Python, but it can be safely ignored when dealing with immutable basic types, numbers, strings, tuples. However, aliasing has a possibly surprising effect on the semantics of Python, involving mutable objects such as lists, dictionaries, and other types of stuff, variables. Usually used to the benefit of the program, since aliases have been like pointers in some respects. For example, passing an object is cheap since only a pointer is passed by the implementation, and if a function modifies an object, passes it as an argument, the caller will see the change. This eliminates the need for two different arguments passing mechanisms like Pascal. I think Ada did the same thing. So rather than changing it every time you move it around, Python keeps it. So if you have a list, inventory, you can pass it around freely. You can change it in, each class, each room in your game that's a class or a function. Anytime you change, the user inventory list, you don't have to, like, as you pass it to the next one, you don't have to say, okay, does this have this? Yes, then add it in this class or this function. You can just pass it since it's immutable. Lists are mutable, dictionaries, variables, stuff like that. So Python got some stuff right. IMHO. Do I want to talk about namespaces? No, I don't want to talk about namespaces. Yeah, let's do this example. I'm going to give you guys some coding. So this is going to be an example of namespace, something you can give to objects or classes. So we'll do like the example, so I don't run into any issues later. I don't think it really matters. But I'm just going to tab. I'll have to go back and keep doing stuff over and over. Okay, so we're just going to tab. Makes me kind of hungry. Of course, there's always errors. Okay, so that's what it's supposed to look like. So fix it as you wish. Okay, so this is kind of showing you the difference between local and global namespaces. So this is what we get. So notice how the local assignment, which is the default, which is that top one, so right here. Notice how it didn't change scope test's binding of spam, because in scope test, nothing really happened, right? It remained as global spam. The non-local assignment changed scope test binding to spam, and the global assignment changed it to a module level. And you can also see there was no previous binding before the global. So whenever we just print whatever spam is down here at the bottom, what is it? What keeps it? Like, what does it? It stays as global, right? Because it can actually reach in there and pull that out without having to. Because this right here, this is just doing the whole thing, right? Clear as mud.
Mm-hmm.
Good. It should be. So let's look at some classes. Let's actually talk about a class. This will make sense when you start doing objects within their own classes. Depending on how you classify them, will change markedly how they react to other stuff. So, like I said, don't just absorb what you can from this. Don't feel the need to completely comprehend it. Just know that this stuff exists. And this kind of stuff is like the real hurdle of going from, this class to like someone who works at a place and does coding. Once you can get past, you know, the small scope of what we've been doing from this entire class to the more grandiose scheme of object orienting and stuff like that, then you can start becoming a real programmer. Because everyone starts off with like, oh, I can print hello world, this is easy. And then they start getting into classes, methods, and stuff like that, and they're like, I don't want to program anymore.
Hmm.
That's what I did. Because I didn't understand it initially. Granted, I'm relating all this stuff to what I know about Java, so I'm sure there's some stuff in Python that I don't fully understand, which is why Roy's going to come in. He has a little bit wider grasp of this kind of stuff. I think he's either going to do a recursive turtle thing that draws a bunch of cool stuff, or he's going to show you guys how to make a website grabber. Essentially, you can go to a website and grab any information on it that you want just by running a Python script. I think he's going to do that one. So I just want to give you guys kind of a leg up whenever he comes and talks about that. It may be Jairus. I'm not sure. It's either going to be Jairus or Roy that comes and talks. And since they already have the program built, I don't have to do it. So everyone got that down that wants to get it down? Okay. So I don't want a whole bunch of questions about this. I'm going to try to make it a little simpler on Tuesday. So don't email me, Professor McWaters, I don't understand any of this. I expect that. So classes introduce a little bit of new syntax, 3 new object types, and some new semantics. So the simplest form looks like this. So statement 1 through statement n, however many statements you have. So what is that? I mean, it looks like pretty much it looks like a for loop, or looks like a kind of looks like a function. So you do have to put a colon in there. So that's just what they look like. This one actually doesn't do anything. This would bark at me for not actually doing anything. But so class definitions, like functions, have def statements and must be executed before they have any effect. You could conceivably place a class definition in a branch of an if statement or inside a function. So in practice, the statements inside a class definition will usually be function definitions, but other statements are allowed and sometimes useful. The function definitions inside a class normally have a peculiar form of an argument list dictated by calling conventions for methods. Again, don't worry about that right now. When a class definition is entered, a new namespace is created and used as the local scope. Thus, all assignments to local variables go into this new namespace. In particular, function definitions bind the name of the new function here. So when a class definition is left normally via the end, a class object is created. This is basically a wrapper around the contents of the namespace created by the class definition. We'll talk about this later on. The original local scope, the one in effect just before the class definition was entered, is reinstated and the class object is bound here to the class name given by the definition header right here. Notice that is boldened. So class objects support 2 kinds of operations: attribute reference and instantiation. What's instantiation? How would you instantiate something?
I have no idea what the word even means. So
Brackets.
That's how you'd instantiate a list. Essentially, what instantiate just means to create it, like to start it. Like if I want to make a new list but I have no idea what to put into it, I'm just going to go, I have instantiated new list. It is created. Or I can say, so I've instantiated it right then whenever I created it. You can also say new list equals, variable 1 plus. So as you're doing stuff throughout your program, so you can do it like that. You've instantiated. It didn't exist before this, but now it does. That's what instantiate means. So attribute references uses the standard syntax for all attribute reference. So object dot name, whatever you call it, Lee dot height, whatever. So let's do an example of a class. Oops. No brand new tabs because it's easier. So essentially what we've done is we've created within that 2 attributes. What have we created? We've created I, which is equal to 123,456, and we've created myClass.f, which essentially just returns hello world. So I think we can just say I think this will do it. No, we didn't actually call it. Why do they always remove the feet on these? How do you call a class? I forgot. Let's see if this does it. There you go. Well, didn't work either. Well, that's fine. I think we have to actually initialize it in order to do that. Yeah, we'd have to invoke it. We'll talk about that later. Yeah, that's fine. Let's look for something. Yeah, that's fine. Ah. So essentially what we're doing is we're calling I from that class. But we haven't run that function, essentially, is why it's not doing what we want it to do. And I forgot. I think you have to instantiate it, which is a whole nother bear, and we'll talk about that. I'll make an actual program that does a little bit more than this. And I myself bone up on this a little bit, because like I said, it's quite a bit different than Java. But what if we just do, what do you think that's going to do? Nothing, because it doesn't exist outside of my class is encapsulated within it. I think I know why that's jacking up. No, that's right. It's supposed to be like that. Let's try something real quick. It's still not instantiating. Oh wait. Yeah, so it's still not being. Essentially, what this is calling up is a spot in your memory. But since I'm not doing the underscore initialize, it's not actually doing anything. So, and we'll talk about that on Tuesday. This is just kind of the little I wanted to give you guys of that. Let me see if there's anything else that's good. There it goes. So I forgot to put the parentheses. Since it has self, you don't actually have to do anything. So there I came up with hello world. Because essentially, this is telling it to run within that. I think you can you do my class? No, because you're not actually, you're essentially what I'm doing is telling it to print this, which it's just a spot in memory because I haven't actually done it. Whenever I assign it like that, it's actually being run, it's actually being done. You're running my class and then x.f, so. But like I said, you guys thoroughly confused? You got it?
Yeah. You just defined F, and then the reason why you put self is self.
Just point it to itself, yeah, just do that.
Whenever you call F the function F, because you defined it, or you defined F, and then you're saying, F is returning hello world. So the reason why it wasn't printing as, my class is because it wasn't actually assigned anywhere yet. You were just defining it. And once you put X equals my class, you assigned it a role, then you can call it.
See, that's actually really good. It's a lot better than I could probably explain it.
Basically, just assigning as a variable so it knows what to call.
Yeah. You have to get, and because I'm not just assigning F, I'm assigning this entire class is equal to X.
Yeah.
So essentially, I can move outside of it now.
But under that class, you assigned I as that, so you can print it. You had not defined or assigned F yet. You just defined what F was.
There you go.
So after you assign it, then you can print it.
There you go. Very eloquently put. Much more eloquent than I probably could have done it. So I just would have said, you can't do it unless you do it.
Which makes sense too.
Yeah, which makes sense, but he explained it why. So that's good. It's sort of coming back to me. I need to bone up on Java so I can start writing Android apps. Because I have a really cool Dungeons and Dragons campaign that I made. And I figure if I can just release a couple chapters here and there, I could probably make a little bit of money. Because people love the text-based games on, well, I do, so shut up. But
I'm also self-teaching myself Java right now.
it's rough, man.
It's so stupid. But I also want to do it for a job, so.
Everyone needs Java. Java is the most commonly used object-oriented programming language. So.
I have a question.
What's up?
So I did everything right there. Instead of doing print x.f, I put that at the bottom,
Mhm.
and it still comes up the same way. But if I put it on a different line, is it supposed to print the way I put it on there?
What do you mean? Like you moved this down?
Yeah. it's supposed to be the other way?
No. Just because
In the order that you-
it's going to print in the order that you call it. So I'm calling I from my class, and that's going to print. Just because these are in this order, it doesn't matter. Like I can put this in there and never use it, and then I can just use whatever is here. Essentially, I'm telling it to print within my class. What is I equal to is what I'm saying here, and it doesn't matter that I.
So the top information is just classification, right? So what it is just explaining everything, right? So you're just writing, technically like writing a dictionary, right? So if you have a dictionary, the dictionary doesn't call itself, right? It's just a dictionary. It's just explanation. Then you can go and use that dictionary to explain things, right? So or do things.
Right.
So you need knowledge to learn, and then you need to learn in order to use, right? So knowledge, learn, use.
Right.
Kind of how it works.
Because essentially, like this could just be my character's name, and every room I enter, it doesn't need to know the character name. It just has to know what I have on me. So, this can be completely superfluous through 99% of your program until you reach the end and it says, Lord loves to spooge is the victor, or Lord loves to spooge died a tragic death to a guru or something like. Just because it's first doesn't necessarily mean that's what it does. Every time you use the class, like think of this as like its own code that's inside of your code, but not accessible unless you call it.
I think it was like an alphabet. The alphabet doesn't actually have an order, but you learned it in a specific order.
Right.
But you can use it however you want.
It's essentially just like it's kind of like a dictionary. It has stuff in it that does stuff, and you can call any part you want at any point, as long as you run it, and as long as you instantiate it, which is what this essentially does. Instantiates, or doesn't instantiate. This actually does this. So, like I said, it's not super easy, but this is essentially what makes people programmers, is getting their mind around this kind of stuff. And it's not hard. It really isn't. It's just new. Up until now, we have done everything just line by line. Nothing called, because like right now, like if I cut this out, this is not doing anything other than creating a little bubble. And if I could write an entire code and not ever use this, and whenever I run it, it's going to assign it, and then that's it. Nothing's going to happen. It's never going to run this. The def f will never run unless I tell it to via right here. So if I can put a massive amount of calculations in here, it'll never do it unless I tell it to. But say, I could call I could put pi in here to 10 billion, letter or number, and if I want to, multiply something by that, I could put the calculation for pi in there, which is not exactly super easy to write out. And then anytime, then I equals all that calculation, and then I could do, radius squared times my class dot pi. It will do that, but not until I tell it to. Does that make sense? That was not the best example, but you could do something like that. So it won't actually. So you won't actually do anything until you tell it to. So that kind of saves. Like if you just say they don't want to do pi. Say you have this. You have what is it? The negative b plus or minus the square root of 4ac minus whatever 2b divided by 2b. What is that called? The quadratic formula. You could put that in there. And if you just hard code it in, every time you run your program, it's going to do that. But if you put it in a class, it's just going to sit there until you need it. So essentially that kind of trims down the memory needed. So it has its uses. For this class, this seems really stupid because like, why would I do that? Why don't I just hard code it? I get it, because we're not going to use classes really that much at all. Although in your final, whenever you make a game, you can use classes and objects, and that'll make it way easier. so much simpler. If you create a character object, and then you create rooms that are classes, essentially the room will never happen unless you go into it. So, and you can make it more modular so that your object is moving around this dungeon, and anytime it goes into a room, it calls that room. Is something you could do. And it only has to be 6 rooms, and you can make it super. Like you can almost do that assignment on like 10 lines, but someone actually did do that. No, I was kind of angry, but I was like, you got me. Yeah, I was kind of proud at the same time. He was one of my better students. Very lazy, but very smart. So that's a good way to be, lazy and smart. Someone gives you a really hard assignment, you're like, how can I do this, meet all the requirements, doing the least amount of work? And people will pay you a lot of money to do stuff like that, so keep that in mind. Any other questions? Like I said, I don't expect you guys just to super duper get it, but I just wanted to kind of touch on it and kind of put it in your mind. Next week, we'll probably talk about objects, and we'll do stuff with objects, and I'll make an objects assignment. And we might have a class, and maybe I'll have you make a class that does something and then run your person. Maybe it's like the gauntlet, and then your object is, the person running through it. Give them like 10 hit points, and in the gauntlet there is a dude with a hammer, a dude with a club, and you can put on like one piece of armor to defend against something like, I don't know. Well, I'll write something fun.
Like a piece of armor that can take 1 hit.
Yeah.
It won't deplete the HP.
Yeah, like hammer armor. I don't know how you differentiate hammer armor versus like arrow armor. Well, I suppose like silk is a very good arrow armor,
You would just do like.
whereas silk is not so great against a hammer.
That's kind of hard to differentiate.
Yeah.
What am I fine with like melee armor and projectile armor?
Yeah. Silk. You want to wear silk armor or plate mail? Because guess what runs right through plate mail? A crossbow. Whereas if you have good amounts of silk, it'll actually get wrapped up in the silk. Still hurt like hell, and probably will still puncture you, but won't go, What was that, Boromir and poor Boromir.